Welcome to this explainer. Today, we're investigating a highly resilient, microscopic menace that's been a relentless adversary to human health for decades. We know it simply as Salmonella. We're going to completely unpack what this organism is, exactly how it operates, and why it's just so incredibly difficult to defeat.
Here's what we're covering today. First, meet the microscopic menace. Second, inside Salmonella food poisoning. Third, how it contaminates food. Fourth, the ultimate survival expert. And finally, protecting your plate.
Okay, let's jump right in with Section 1, Meet the Microscopic Menace, a global pathogen.
According to the source documents, this is a gram-negative, non-sporing bacteria. Now, what does that actually mean? Well, it basically means it has a really complex outer wall, but it doesn't rely on creating protective spores to survive. And what makes it such a formidable threat is just its sheer ubiquity. It isn't found in just one specific place. This bug is widespread across cows, poultry, pigs, and even your everyday domestic pets and reptiles. It is literally everywhere.
Now, biologists have identified thousands of variations of this bacteria, but we can cut right through the biological jargon because you really just need to know that almost all foodborne threats come from a single subspecies. It's called S. enterica, and within that subspecies you've got two specific serotypes, enterotitis and typhimurium. These are the heavy hitters responsible for the vast majority of our current food safety concerns in the US and Europe.
So what actually happens when it breaches our defenses? Let's get into Section 2, Inside Salmonella Food Poisoning, the Human Cost.
The resulting illness is gastroenteritis, and man, it hits fast. You're looking at an incubation period of anywhere between 8 and 72 hours after exposure. Once it takes hold, it brings a pretty miserable 2 to 5 days of severe abdominal pain, fever, nausea, and vomiting. Now, healthy adults usually bounce back, but the true danger lies with our high-risk demographics, infants, the elderly, and folks who are immunocompromised. For them, this infection can be incredibly severe.
Which brings us to a seriously terrifying question. We used to think it required the ingestion of millions of cells, like a minimum of 1 million, to actually cause salmonellosis. But recent outbreak data forces us to reevaluate. How much does it actually take to initiate an infection?
25. Just 25. In a massive 1994 outbreak in the US linked to contaminated ice cream, an outbreak that, by the way, infected an estimated 224,000 people, scientists calculated the infective dose. It took an estimated maximum of just 25 microscopic cells to get someone sick. Under the right conditions, this pathogen doesn't need an entire army to breach your defenses. It just needs a microscopic strike team.
Let's look at how it pulls this off in Section 3, How it Contaminates Food, Infiltration Tactics. Salmonella utilizes multiple entry points. The most direct route is through meat, poultry, or raw milk that comes into contact with intestinal material during processing. But it's also an absolute master of indirect infiltration. Cross-contamination is a massive issue. Think about it. A chopping board used for raw chicken can easily transfer the bacteria right to your salad. It can also harbor and poorly sanitize manufacturing environments, hiding out in mops, on deli slicers, or deep inside refrigerators.
But arguably, its most insidious infiltration tactic involves the egg itself. For a long time, we thought eggs were only contaminated on the outside of the shell, but certain strains, specifically S. enterotitis, can systematically infect a laying hen's reproductive tract. This means the inside of the egg, the yolk and the albumin, is completely compromised before the protective shell even exists. It's the ultimate biological Trojan horse.
Why is it so hard to get rid of? Welcome to Section 4, the ultimate survival expert, biological defenses. This pathogen is built like a microscopic tank. It grows happily anywhere between 7 and 48 degrees Celsius. Think freezing will kill it? Nope. Think again. It can survive deep freezing for literally years. It has an incredible pH tolerance, meaning it survives acid shocks. It highly resists drying out. It actually caused a major outbreak by surviving in dry toasted oat cereal. And incredibly, if you expose it to a sublethal dose of heat, it triggers this complex biological response that actually increases its heat resistance for the future. It learns and adapts.
And this brilliantly illustrates its adaptability. Under standard conditions, Salmonella is totally vulnerable to heat. Normal pasteurization destroys it in minutes. But if Salmonella hides in a food with high fat and low moisture, like chocolate or peanut butter, those exact same heat treatments become completely ineffective. The fat acts as a thermal shield, protecting the bacteria from both the heat of processing and the acidity of your stomach.
To truly grasp its growth potential, look at what happens in simulated kitchen conditions. If you leave an internally contaminated egg sitting out at a room temperature of 20 degrees Celsius for about 3 weeks, the internal membrane breaks down, and once that happens, the Salmonella invades the nutrient-rich yolk. The population doesn't just grow, it explodes, exceeding 1 billion cells inside a single egg. Just staggering numbers.
All right, time for some good news. Section 5, Protecting Your Plate, Countermeasures. We actually can fight back effectively. Look at this dramatic drop in the UK. Back in 1997, there were roughly 31,000 reported cases. By 2006, that number plummeted to just 12,500. So how did they achieve this massive reduction? Largely through aggressive action by egg producers, specifically by implementing widespread vaccination programs for their laying flocks. By cutting off the source, they drastically reduced the human infection rate.
Defeating Salmonella globally requires what experts call a strict farm-to-fork defense strategy. It's a team effort. It starts with agricultural hygiene on the farm, keeping wildlife away from crops and controlling animal feed. In the factory, it requires strict safety controls, known as HACCP protocols. During transport and retail, rigorous temperature control is absolutely non-negotiable to halt bacterial growth. And finally, in our own kitchens, we must ruthlessly prevent cross-contamination between raw meats and ready-to-eat foods. So, the crucial takeaway for you, the consumer, is beautifully simple. Treat raw poultry with the respect a biohazard deserves. Maintain strict kitchen hygiene, use separate cutting boards, and respect the fridge. And most importantly, health experts strongly advise that vulnerable individuals should only ever consume thoroughly cooked or pasteurized eggs. Better safe than sorry, right?
We've definitely learned to fight back effectively against this pathogen, drastically reducing its impact through science, vaccination, and basic hygiene. But remember, we're dealing with the ultimate adaptable survivor. We've seen it develop antibiotic resistance and adapt to incredibly harsh environments. So, as we close this explainer, I want to leave you with a provocative question. As our global food industry continues to evolve its countermeasures, what new biological defenses will this microscopic menace develop next? Thanks so much for joining me today.